Okay, well, we're going to move on into section 7.4, and we're going to talk about working with similarity and similar triangles. And so in the past, we were talking about proving triangles congruent, but we can also prove them similar, which, as we've said, is they have congruent angles, but they have proportional sides. So we're going to talk about what happens when you have two triangles and if two of the pairs of angles are congruent. So let's say we draw two segments here, AB and then A prime, B prime. Then we draw an angle A and a congruent angle A prime. Then we draw an angle B and a congruent angle B prime. So we have angle ACB is congruent to angle A prime C prime B prime. And so how do we know that? Well, if these two are congruent and then these two are congruent, then the third angle has to be congruent. So if we were to go and measure these sides and figure out an approximate decimal value, we would find that these ratios were all the same. So when we have corresponding angles of the two triangles that are congruent and corresponding sides are in proportion, then by the definition of similar polygons, ABC is going to be similar to A prime, B prime, C prime. So if you draw two triangles and two angles of one triangle are congruent to two angles of the other, then you will automatically find that the third angles are also congruent and that the corresponding sides are in proportion. And this is called the AA similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And they give you an example here. Angle H and angle F are right angles. And you want to prove that HK times GO is equal to FG times KO. So the thing we're trying to show is that HK over FG is equal to KO over GO. And if we can show that, then multiplying them across multiplying will end up proving this for us. So really all we have to do is show these two triangles similar, and they'll automatically have these sides in proportion. So we start off with our given. And, they actually put that in the second spot. Angle H and F are right angles. That's given. Angle 1 is congruent to angle 2 because vertical angles are congruent. And then angle H is 90 degrees. That's the definition of a right angle. And angle F is also 90 degrees. And then by the definition of congruent angles, then angle H is congruent to angle F because they have the same measure. They're both 90, so therefore they are congruent. So by this AA similarity postulate, HKO is similar to FGO because we have two angles that are congruent. Angles 1 and 2 by vertical, angles H and F because they're both right angles. So since two angles of one triangle are congruent to two angles of another triangle, then these are similar. And since they are similar, then HK over FG equals K over GO because corresponding sides of similar triangles are in proportion. And then we can just do one of the properties of proportions is that we cross multiply and they're still equal. Okay. So this example, it just shows one way to prove the product of the lengths of two segments is equal to the product of the lengths of two other segments. We started by proving the triangles similar then we wrote a proportion, and then we do the means extremes property of proportions, which is doing the cross multiplying. Okay, so that concludes the brief video for section 7.4, the AA postulate for similar triangles. And so go ahead and do these classroom exercises. I'll put a blank worksheet over here. Please do the problems in the bit paper so that I can go back and grade them. And we'll see you in the next video.